Write the expression in terms of sine only. Negative the square root of 3 over 2 times sine of x plus 1 over 2 times cosine of x. We first rewrite this as sine of x times negative root 3 over 2 plus 1/2 times cosine of x. With our wishful thinking, we want this to be sine of x times cosine of phi plus sine of phi times cosine of x, where again our wishful thinking is that cosine of phi equals negative root 3 over 2 and sine of phi is 1/2. And that is our wishful thinking if we can rewrite it. But if cosine of phi equals negative root 3 over 2 and sine of phi is 1/2, then phi is the angle in the second quadrant. In fact, in the second quadrant, for an angle between 0 to pi, there is only one phi that satisfies both of these equations, and that phi has to be 5 pi over 6. Cosine of 5 pi over 6 is negative root 3 over 2, and sine of 5 pi over 6 is 1/2. With that and our wishful thinking, we can write this as sine of x times cosine of 5 pi over 6 plus sine of 5 pi over 6 times cosine of x. But this is the sum formula for sine of x plus 5 pi over 6. What we just did is we wrote the given expression in terms of sine only. There's only one term here with sine, and that is what we want. Now, there is another easier way to do this, although to do it using the easier with the procedure, there's a method to do it. We have to know the formula. There is a formula that would rewrite the sums of sines and cosines, and this is precisely what it is, the sums of sine and cosines. It states that a sine of x plus b cosine of x equals k times sine of x plus theta, where cosine of theta is necessarily a over k and sine of theta is b over k, where k is the square root of a squared plus b squared. The expression given is negative root 3 over 2 sine of x plus 1/2 cosine of x, and it resembles this formula. This is called the sums of sine and cosine formula. So we would compare it to a sine of x plus b cosine of x. We see that a has to be negative root 3 over 2, where a is the coefficient in front of sine, and b has to be 1/2, where b is the coefficient in front of cosine. K in the formula is a squared, negative root 3 over 2 squared plus b squared, 1/2 squared, and then we take the square root. This is 3 over 4 plus 1 over 4, which is the square root of 4 over 4, or 1. So k is 1 in this case. To rewrite the sums of sine and cosine using one term's sine only, or in terms of sine, we need to find k, which we did, and we also need to find theta. But theta have to satisfy the condition. Cosine of theta has to be a over k. A is negative root 3 over 2, and k is 1. and sine of theta has to be b 1/2 over k. So cosine of theta is negative root 3 over 2, and sine of theta is 1/2. Regardless, we still need to find out what this angle is. Cosine is negative, so we are in the second and the third quadrant. Sine is positive, so we're in the first and the second quadrant. So this angle theta has to be in the second quadrant. And we see that the only theta that satisfies this condition for an angle between 0 and 2 pi is 5 pi over 6. And so if we were to rewrite the given expression, this is of the form k is 1, sine of x plus theta is 5 pi over 6. We end up with the same answer we got before, but at least we didn't have to have wishful thinking. We know the procedure. We can find k and theta this way.